All right, so let's talk about derivatives of inverse trigonometric functions. Honestly, this is just another set of rules that you can either know or know how to derive on your own. The same sort of things that you've been doing with derivatives all along still apply here. You're still going to have product rule, you're still going to have chain rule, you're still going to have quotient rule, and you're going to be mixing in inverse trig functions into all of those. And so this is simply the idea here. It's just the derivative of the inverse sine of x is 1 over 1 minus x squared. Now, if that was the derivative of the inverse sine of some sort of function of u, it would be 1 over 1 minus a square root of 1 minus u squared times u prime, where u is some sort of function of x. So that would be like a chain rule application. So basically, you just need to either know these or know how to figure them out. So my goal for right now is to show you how to figure them out, because I never got around to memorizing these. I just honestly didn't care to memorize them, because why would I when I could figure it out on my own? So if we have the inverse sine of x and they want us to find the derivative of this thing, the way that I always approach this is I like to say, well, I don't remember. I don't remember the formula. So what I'm going to do is I'm going to say that this is equal to something. Let's call it alpha, because the inverse sine of something will give you an angle. Because normally the sine of an angle gives you a number, so the inverse sine of a number gives you an angle. So what that means, the inverse sine of x equals alpha, what that means is that x is equal to the sine of alpha, whatever that angle is. Or, in other words, I'm going to draw a picture over here for you. If we have a triangle with an angle, alpha, the sine of that angle, so sine is opposite over hypotenuse, is going to be x. So this triangle right here has this angle, alpha, has a sine of x. Now, I'm going to go ahead right away and say that this third side here is going to be the square root of 1 minus x squared, which you would get from the Pythagorean theorem. So, like if this down here was like b, you could say that x squared plus b squared equals 1 squared. So x squared plus b squared equals 1. So b squared equals 1 minus x squared. So b is equal to the square root of 1 minus x squared. You know how to use the Pythagorean theorem. So anyway, that's what that third side is equal to. Now what I'm going to do is I'm going to take the derivative of this thing here, x equals sine alpha, and I'm going to have to do implicit differentiation because alpha itself was originally defined as a sine of x. So the derivative of x is just 1 equals the derivative of the sine of something is the cosine of that something times the derivative of that something, alpha prime. Okay. Now, alpha prime, well, so the next step would be divide both sides by cosine alpha. Cancel, cancel. We get alpha prime equals 1 over the cosine of alpha. All right. So, originally what we had was our function was equal to alpha. So the derivative of alpha is the derivative of our function. So here is our derivative. Now, originally, we started off with some sort of a function of x, right? But we've gotten here to alpha prime equals 1 over cosine alpha. So what we need to do is we need to go back to our triangle, and we can see that the cosine of alpha here would be the square root of 1 minus x squared divided by 1, or just the square root of 1 minus x squared. So the derivative, so alpha prime, is the derivative of what we originally started with, which was the inverse sine of x. That's going to be equal to 1 over, well, cosine of alpha is the square root of 1 minus x squared. And hey, take a look. There's the rule. So, if you can't or don't want to memorize these rules, there's a way around it. And I just wanted to show you that real quick so that you could see that. Now again, same sort of applications that you're going to be doing with every single other derivative that we've learned so far. Once you find a derivative, you're going to find slopes of tangent lines. You're going to find equations of tangent lines. You might even find maximum or minimum values. We're going to do a lot more of that application stuff in the next chapter, but it's the same as every other derivative rule. I hope this video helps, and if you have any questions, please let me know.